Welcome to Rges Algebra 2. This is lesson 3.1, linear functions. Now, a linear function is a function whose general equation, one of the forms of the general equation, would be y equals mx plus b, where m and b are constants and m does not equal 0. That means there must be an x term to this, both an x and a y term. Notice what we have is x and y are not squared, cubed, anything else. They're both to the first power. Now, we call it a general function because everything is represented by a letter, whereas if we wanted to call it a particular equation, okay, we would have something like y equals 3x minus 7. This would be a particular form of the general equation where the constants are plugged in. Okay. Now, this will graph to a line. So what they're asking you to do is they're asking you in problems 1 to plot the graphs of the following functions by selecting values of x, calculating the corresponding values of y, and plotting. So I'm going to do the first one for you. It means you are going to actually make yourself the t-chart with values, choosing values of x, plugging them in, and getting values for y. So the first one is y equals x plus 5. And so you would choose, let's choose 0. And if we plugged it in, y would equal 5. If we chose 1, y would equal 1 plus 5, or 6. If we chose negative 1, y would equal negative 1 plus 5, or 4. Okay. And that's really, for our purposes here, probably sufficient. This would be our y-axis. This would be our x-axis. Recall the x-axis speaks about the domain and the y-axis about the range. The x-axis is the independent variable, the one I'm choosing values for, and the y-axis, or the y, represents dependent variables, the variable on the left side of the equation that its value is going to depend on what I choose for x. So let's plot those. 0, 1, 2, 3, 4, 5. Would be my first one. 1, and now we're going up from 5 to 6. Whoops. And then negative 1, it's 1, 2, 3, 4. And we could plot more points to convince us, but this is indeed a linear equation. Okay. And because it plots to a straight line. Is it a function? It is a function because of recall the test that I can make for whether or not something's a function. It's a vertical line test for any point along here where I have a certain value of x. I only have one y, represented by these points right there going up. So it is a function. They're asking you to let's see, plot the graphs, okay? And that's all you need to do. So they're asking you to do that 6 times. I've done the first one for you, so go ahead and do B through F, and that's just practicing plotting by, of course, using the plotting the graph by using a table. Somehow I managed to delete all that real quickly. That's all right. Now, number 2, on page 74, the next section says, why are first-degree functions called linear functions? That you should be able to answer on your own. What does a linear function mean? B, first degree meaning x is to the first power, right? And y is to the first power. We don't have a squared or a cubed in there. What is the effect on the graph of changing the x coefficient? That's a good question, okay? If I had y equals 2, well, let's see. Let's just say y equal x plus 2. When would y equal 0? What would I have for negative 2 for y to equal 0? Can you think that through for me? If my y equals 0, what would I have to have here to make that true? Well, this would have to be a negative 2. So when x is negative 2, then y is 0. I could choose 1 to each side of that well, that's just 2 to each side of that. Negative 4. Negative 4 plus 2 is negative 2. And how about 0? 2 to the right of my negative 2. And that would be 0 plus 2, or 2. So graphing that very quickly, I'd have negative 2, 0, negative 4, negative 2, and 0, 2. And again, I'm getting a line. Okay. Now, if I instead had y equal x plus 1, what would that look like? I'm going to go ahead and make another color here. Well, if I'm thinking about here, when would y equal 0? If x is negative 1, then I could have negative 2 and 0, 1 to each side of that. If it's negative 2, negative 2 plus 1 would be negative 1 here. And if it's 0, the y value would be 1. So let's plot that. I've got negative 1, 0, negative 2, negative 1, and 0, 1. And notice what's happened here. I have changed my value of what? Okay. I haven't changed the x coefficient, that's b, but I have changed the constant term. I changed it from 2 to 1, and that has shifted my line. Does that make sense to you? So if I had another one here, and I made the constant something else, it would shift my line. They would be parallel lines, but where they cross in the y-axis would be different on each one. Now what if instead, notice both of these have a x without a coefficient in front of them? Let's change that. Let's say y equals 2x plus 2. And now I've changed this. I'm comparing it to the first one. Let's go ahead and make a chart here. Let's go 0. This would be 2. If I said 1, this would be 2 plus 2, or 4. And if I said negative 1, this would be minus 2 plus 2, or 0. Let's plot those three. I better choose another color since I've already used this orange. Okay, so I'm going to plot this in purple now. And I'm comparing it with red because it's the same equation as I had up here, except I've changed the constant in front of my x. Now let's see what happens. I've got 0, 2. Then I've got 1, 4. 1, 2, 3, 4. And I've got negative 1, 0. Now this line, it's still a line, whoops, missed it, and all of a sudden, what has changed between that line versus my red line? I have a steeper slope, don't I? So when I change the constant in front of the x, it changes the slope of the line. Notice the other way, I had the same constant, like a 1, in front of my x for the comparing the blue one and the red one, and the slope of the line did not change. So you try to figure out the rest of that on your own. I'm giving you some hints there. If m equals 0, as in part F of problem 1, the graph is a horizontal straight line, yet the function is not called linear. Okay, why not? So if we just have something like y equals 0x plus 5, of course 0 times anything, I can simplify that to y equals 5. Where does y equal 5 on a graph? Y equals 5. Recall, the the y-axis, right? So it would be, there's a 5 for y. If my x is here, there's the 5 for y. If my x is here, there's the 5 for y. On and on, right? Lots of points. It's a horizontal line going through 5. So we do not call that a linear equation, even though it looks like a line, because it's a special case, and we call that a constant function. A constant function, because the y value never changes. FNC stands for function. Okay, so that's about it. I think you can do the rest of that. Make sure you do all your graphing in section 1 and look at the questions for section number 2 again.